So, hello once again. So, in the previous recorded video, we saw that like when we compile the code, we get information about different sections and so on. So, we'll try to get more information about these commands which are used or utilities available. So, this size actually is used to display section sizes in binary. Okay, what are the binary file that is created by us? Okay, because if I try to display, say, this file, it says it is a binary file. You cannot check the content. Right? See, do you want to see it anyway? So it would be showing this thing. So few things probably might be readable, but maybe we'll skip it for a while. Okay, similar thing would be like similar thing would be there for your .o as well. Like it is a binary file, and that's what like we are using this size command to show the sizes of different sections like text, data, BSS of an executable or an object code. Now the format that I used is, first of all, you create your object code or you create your executable and then use this size command. And the output that is shown here is like, first of all, it shows text, this size of code section, which is exactly the translated instructions. Okay. Data shows you the size of initialized global or static variables. And BSS, block starting with symbol, shows size of uninitialized global or static variables. Similarly, if I see that DEC and hex shown, this is the total size of the code or that file exactly in decimal and hexadecimal. Okay, and then this would be good for checking memory usage in a binary file. The second, now I would be showing you one more command. If you recall, like we wrote this code rather. Okay, and with this code, we saw that in that code we used say two global variables. Okay, three global variables. Two of them were initialized, and one of them was not initialized. And third one, the fourth one, which we used rather as a local variable. Now, when we saw that the size is changing from BSS to data and so on. Correct. So if I go and create my executable again, okay, for this, and if I check size, you should see that we used here in the code, this was our code, correct? So as we are seeing it for a.out, that's why this is shown. And if I check with your online.c, online.o, then ultimately you should see the respective one. But on what basis we are saying that this is going into data, this is going to BSS? So I'm introducing you one more command. So let me arrange the screens like this so that we can have a look on other things too. Okay, so let me show you one more command which is used generally. So this command is called as nm. Okay, again, and utility. Fine. And this utility is used to display symbols in an object file or executable. So if I display this, it is again from the tool chain, GNU development tools. You can see this. Okay. Now, if at all we use this rather to display the output. So as we have object code created, let me write it like this. So you will see that there are few things added over there as an output perspective, as a command. Like as we are providing that input file uh, as an object code to nm command. As I stated, this nm command would be displaying symbols, generally the function names and variables from an object file or an executable. So generally, like as an syntax perspective, what we did was we wrote nm and then we wrote executable name or object code name. So right now I wrote object code name. So you will see that there are few symbols used over here. Say for example, there is capital U, capital D, capital B, correct? Now, each of these symbols are having specific, say, representations. Okay. of the different sections. And towards left side of this output, you should see the addresses. Okay, the address is generated. So like as we saw that like in the code, this was my first variable, okay, which was initialized, and this was my second variable, which was initialized. So if address of this section starts at 0, as it comprises 4 bytes, so next address will start for this as 4. So you may see here. So for global first, it is 0000, correct? One can see that. And for that global var, which was initialized one, shows 4. Correct. I will try to show that again by making the changes in the code so that you will understand what exactly I'm trying to tell. Even like if you see, we are using a printf function, which is a library function, correct? So this library function is not yet available because we are seeing it with .o, correct? That's why it is added there, but it doesn't have any address, right? So now if I try to understand what exactly is meaning of these symbols that are shown in between the addresses and the names. Okay, so capital T shows a text section or code section. Generally, mostly the name of the functions are added there, which are used by you in the text form or code part. Capital B tells you as a part of BSS section, which you already talked about by saying them that they are uninitialized global or static variables. Capital D tells about data section, initialized global or static variables, and capital U here is undefined. That means they are external symbols that would be picked. Symbols, I mean to say the function names rather, because everything goes into symbol, and generally it is known by whenever we do talk about any translator, there is a data structure used by the translator to translate the code, and it is called as symbol table. So that's why each variable, each function name, each identifier is added into symbol table, and that's why I'm saying that the symbols. So you specifically tells you that they are undefined right now. It doesn't have any information about them. That's why they are external symbols from link libraries. Okay, like in this case, what are the output that we are seeing here? One may check with this that like the global offset table and printf is with you. Correct. Now, if I add scanf over there, you will see again you there. Correct. So let us make the change in the code. Let us write. Let us make small modification in the code. I will add 2 variables here again. Okay. Let us do this so that you would be able to find var1. So now these are the different variables. So now as we know now, there are how many global variables? There are 1, 2, 3, 4, 5. 5 global, 1 local. Local would not be shown there. Local goes into the stack section. And we'll see. I already showed you through the assembly code where the value was shown in the previous session. So if I now create again the object code, say for this, okay, and now if I apply size, sorry, nm, now try to see like now we have 2 variables. One is second, again, other one is again. Correct. Now, don't worry about the order that is added here. So if second is the first uninitialized variable from BSS section, so its address would be 000. So if I see this, its address is 000. Now another variable that was added by us, which was not initialized, it is global again, correct? And this is next to second. That's why in BSS, its address is 4. Now we had 3 variables which are global and initialized one, first, var and var1. So I'm not reading them the names completely, but let us consider them. Say for example, if I talk about global first, in global first, its address is 0. Now next variable which is initialized is global var. So I can see that it is at 4. Now global var1 goes to 8 now. So ultimately this is how the addresses are added. Okay, now let us make the change and let us add here one scanf. Simply scanf %d, sorry, %d. ampersand, and let us give name, say int global again. So I am reading value for this. Okay. Let us hope everything is quite okay. Let's check variable names. Yes. Save this. Now let me assemble this again. Correct. And let me display now the symbols. Now you will see that the way that printf was shown as u, scanf also is added as u now. Correct. Now if I go and check with the nm command, man page of nm command, you will be able to see that there are multiple options provided, and each symbol that is added there in capital tells you what exactly they are. So for example, capital A is whenever symbol's value is absolute and will not be changed by further linking. Capital B, BSS data section, okay, uninitialized one. Capital C is for common, okay, and these are the different sections added in the code. So maybe like I showed you with NM for say object code, and if at all I apply with a dot out, I have to use less here now. You will see that multiple such things are added there. Correct. Now, like there are addresses changed. So, what are the variables that we had earlier? Like if I come out of this code and if I display here nm online.o now, and if I check here, now let us try to see whether can we see the variable names there. Yes. So these are the variables. Now check these addresses like int global first. Here it was available at 00004. Okay, like a 32-bit address. Correct. Now here, the like if I see it is 4008. Second is available at 4014. If I check this, it is 000. So the sections are not changed, but their addresses are changed. So now you will understand here that this is called as binding. So what are the object code that we created here? This is compile time binding, okay, that we got here. And this code was linking time binding. And probably when you run the code, you will have different addresses at runtime for these variables. Correct. So this is the output of nm command, which you can check particularly. So as we stated here, this NM would be mostly used for getting information for debugging, sometimes checking the symbols, and sometimes you may wish to understand how functions and variables are stored. Correct? And that's how rather we do see this. So these all addresses, these are shown here for a dot out are linking after linking time binding. Now you may see like for printf again, if I go back, this printf is still undefined, correct? I may check for scanf2. Say for example, let us see whether can we see find can we check for scanf somewhere. So printf can be seen. Now why scanf is not there will work out. Okay, right now at least we saw that the functions names are added. Correct? No, sorry, we haven't created the executable for this. That's why the scanf is not shown. So let me create an executable. Okay. Because of that only that scanf was not added. Now you should be able to see now that scanf. Okay. Now if I go back and if I apply nm a dot out, you should see scanf now. Yeah, you should see scanf. Correct? Because we used this earlier created file. That's why the things are not shown. Fine. So this is how we use this nm command. Okay. Further, like if at all you do want to see the referred, like talked about symbol table data structure. So to know that, you can use this command. So say man readelf. So this displays information about an ELF file. So readelf, say dash s, and you type say file name online.o. So let me maximize this. So you will see that this is symbol table. These all are the variables that are added. Correct. And as we are seeing it from .o, so you should be able to see this. And like wherever the thing is, like as I was stating about capital U, saying that undefined, so you can check this UND, UND, UND. Correct. And like these are the things added. Now I haven't talked anything about RO data. So let me tell you what exactly this RO data is. Now, what are the messages that we add in printf? Okay, so let me say when I go and generate assembly code. Now you may recall we added scanf, %d, and we added printf. Okay, there are two things which are included in double quotes for both the functions. So now if I check this online.s, what happens is in RO data, it is called a read-only data. So in RO data part, it adds this both the things, and it gives the local variable name. So .lc0 is the first variable that is created by it as a variable, local variable, to store that string which is included into double quotes. So what are the messages that you write in printf or scanf? All these messages would be added into RO data. Correct? So like if you add again, say a few more printfs and scanfs, rather, all those messages would be coming over here. So .lc0, .lc1, and one can check even below, like whenever scanf is, like if I go below and see the scanf statement, you should see reference to yeah, you should see reference to that .lc0 because it is used there. And for printf, one can see .lc1, the message. Correct? Like these are used over there as an reference perspective. Okay, and these are the local variables added. So sometimes you may skip rather these this RO data. You can add that into data section only. But generally, the standard habit says, or whenever you are writing the program or assembly code, rather, every time whenever you see that some value which is not going to change across, it should be added into RO data. Okay, and like you will see that this data, this information is never added outside. Like for example, when we talked about NM, okay, and when I wrote this .o, information about those local variables is not shown here because those local variables are handled via stack. Okay, and what I applied to see the symbol table was this command online readelf -s online.o. This dash s ultimately communicates you that you can display symbol table from this. Now you may wonder, like when I use file command, say for example, with this and file command with my object code, okay, it how exactly it is identifying this. These are the types. Okay, ELF 32-bit LSB relocatable, ELF 32-bit LSB executable. So this file command tells you the type of the file, and this is useful always for checking if a file is executable, script, object file, or whatever. Correct. Now, how exactly it does? How exactly it does? So what it does is it reads the file header. So every file, when you talk about file system, rather, when as an a data structure perspective, file always had a header. Okay, and that header contains information about the type. So if I have to see like a header of this object code, because of which it categorized it as executable or a relocatable object code and so on. So for that purpose, we have to use readelf and write -h and then simply write say object code name. It will contain sorry, I have I should have included space. So it shows me this magic number. And this magic number is the type of the file, and it displays multiple things. Like one may see here, okay, how many sections are there, what is the size of program header, where what is the type of the file, how data is stored. So once we go further, like when we see few more details about this, you will understand what exactly do we mean by little Indian and two's complement approach. Okay. Now, you must have heard about something called as application program interface. Similarly, there is something called as application binary interface, ABI. So this is ABI version. Okay, ABI information. Your machine information also is shown, and that is the reason, like why you see this as Intel 80386. So it reads from here, correct, from the header, this information. Okay. So what command we used here to get this header? So you should write this readelf dash h on line.o. And similarly, like if you see the code is 75454C46. Now if I check it for this, it is again 754C 7F454C46. Correct. Now again, like for both, it is showing the same thing. But then where is the difference? You can check here. It is position independent. Like there is something written as PIE. Correct. If you recall, when we wrote this file a.out, it shows us PIE. This PIE is position independent executable code. And your object code is relocatable so that when executable is created, you don't know within like from line number 1 of executable to line number last, okay, where exactly your code would be fitted, your object code would be fitted, and that's why the code is generated as relocatable code. Correct. And I will tell you, like again, I will repeat the command. What we saw was we used we tried finding out details about nm, details about size, details about file command. Further, we saw the addresses generated, and towards end we were talking about the header, which is used by file command rather for every file to know what you can call it as magic number of the file, and this magic number tells you file type. Now exercise for you, what you do is try to search maybe like what are the magic numbers for other file types. So if you have any other file type available here, say for example, let me go and check with downloads if I have something. Yeah, suppose for example, if I say this particular one, okay, or if I will get this PNG, okay, or PDF, say file test underscore 01 PDF. So it tells me that it is PDF document, correct? So if I say, if I use that video file name, then it tells me that it is a media file MP4 version. Now, the exercise I am talking about, earlier what I said was try to get types of, sorry, magic numbers of these files, which is used by the file command to identify the type. So can you write the code rather, which will take input a file of any type? You should be able to read header of that file and should conclude by telling that, okay, this is of this type. So the way that it is showing us here, for example, earlier it showed us PDF document, maybe earlier it showed it is object code, or maybe relocatable code, ELF, PI, position independent executable, and so on. So try writing this kind of code and submit it on Moodle. Thank you. It would be great rather like if you can read, if you can write a program which reads a binary file, because these all files, if I try to display, okay, I will not be able to display contents of this because it always says a binary file, correct? So can you write a code, C code or a Python code, whatever your choice is, which should read this file, open this file in binary mode, try to check the header. Header would be at the start only. Okay, at the start of the file when the file is stored on the disk. Okay, try to read the type Okay, read the magic number. Have magic number stored somewhere here. If you go to Wikipedia or if you search on Google, you should be able to get different magic numbers of the files and try to generate this kind of output. Like this is program. Say for example, I wrote that program. So output of Nitin Patel program. The file type you provided is XYZ. So this should be the output, for example. Okay. So best of luck. Try to write that assignment. Try to complete that assignment. Try to write that C code or a Python code. For that purpose, you will require knowing about all magic numbers. Collect that information from various internet sources. o- uh, r- Understand how to open a file in binary mode. Open that file in binary mode. Read the magic number when and match it when magic number matches. Then you conclude that this is a type of the file.